Hello class, today we're going to be talking about this equation and some questions related to this equation. First, we gotta balance this. There are 6 fluorines on this side, so there need to be 6 fluorines on this side. Since there's 6, there will be 6 hydrogens, so there's only 4 here, 4 hydrogens here, so there should be a 2, and that will be 6 hydrogens. And we will have 2 oxygens on each side, and that's balanced. So this is the type of replacement equation. It's not single, it's not double, because it doesn't fulfill any of those requirements for single and double replacements. So we have 35.5 grams of SiO2, 66.5 grams of HF. We need to find the limiting reagent for these two. So there's 35.5, 66.5 grams. This one's the one because it has a less gram.
Teacher,
Yes.
I have a question. I think you need to determine limited reagent based on the mole of the products that created by those two masses.
Yeah. Are you sure?
You're not a good teacher.
Oh my god, come on.
Let me tell you how to do this. So let's actually convert those two masses to the mole of the same product, which let's say H2SiF6, which is called hexafluorosilicate acid. So we have the mass of silicon dioxide, which is 35.5 gram. And then we convert it, which we're dividing by molar mass of the silicon dioxide, and then we will have the mole of the silicon dioxide that used it in the experiment, and then we convert this mole by times the molar ratio between H2SiF6 and the silicon dioxide, and then we'll finally equal to the answer of the mole of hexafluorosilicon acid, which is 0.591 mole. Let's look at the mass of hydrogen fluoride, which is 66.5 gram, and we're dividing the molar mass of the hydrogen fluoride, and then we have the mole of hydrogen fluoride, and we times the molar ratio of H2SiF6 and FHF. So finally, this equation is equal to 0.554 mole of hexafluorosilicate acid. Now we got the number of the mole of H2SiF6. And let's look at it. So, if at the beginning of the experiment we use 35.5 gram of silicon dioxide, we will create 0.591 mole of hexafluorosilicon acid. And if we at the beginning of the experiment we use 66.5 gram of hydrogen fluoride, we will create 0.554 mole of hexafluorosilicate acid. If we compare these two numbers, clearly this number is smaller, at which this mole is created by 66.5 gram of hydrogen fluoride. And so we can determine that the limiting reagent is hydrogen fluoride. And the reason is that if we use 35.5 gram of silicon dioxide in this experiment, it won't limit the reaction. It will create more products. But instead, if we use 66.5 gram of hydrogen fluoride, it will limit the experiment because they will create less products. So since we know that hydrogen fluoride is the limiting reagent, let's calculate how many moles that used it in this experiment. We have 66.5 gram of hydrogen fluoride, and we divide it by the molar mass of hydrogen fluoride, which will equal to the mole of hydrogen fluoride, which is 3.32 mole of hydrogen fluoride and equal. Great. So now we have 3.32 moles of hydrogen fluoride, in which we times the molar ratio between silicon dioxide and hydrogen fluoride, which is 1/6. It will give us the answer of how many moles that being used in this experiment of silicon dioxide, which is 0.553 mole. So now we have 0.553 moles of silicon dioxide, and since the hydrogen fluoride is a limiting reagent, let's see if based on the mass of hydrogen dioxide that used it in experiment, let's see how many actual mass that for silicon dioxide that used it. So we use 0.553 moles of silicon dioxide times the molar mass of silicon dioxide, which will give us the actual mass that has been used in experiment, which is 33.2 grams of silicon dioxide. Since in the question it says there are a total 35.5 grams of silicon dioxide, and then based on the last equation that we calculated, we have there were 33.2 grams of silicon dioxide that's actually being used in the experiment. So when we minus them, we will have the excess of silicon dioxide that is not being used in experiment. And that was all of the question part A. Let's move on to part B. It asks to calculate the theoretical yield for hexafluorosilicic acid, which is H2SiF6. And since we already calculate the mole that has been created in the experiment, which is 0.554 mole, then we times the molar mass of H2SiF6, and which eventually will give us minus plus together equal to the mass, the theoretical mass that will be created for H as a product of H2SiF6, which is 79.84 gram. And that was question part B. So let's move on to part C. It asks for the percent yield, which we will use the experimental yield for hexafluorosilicon acid divided by the theoretical yield for hexafluorosilicon acid and times 100%, which is equal to 57.36%. Yes. So in the question 4, part A, that we have been calculate the excess mass or leftover mass for silicon dioxide, and the answer was 2.3 grams of silicon dioxide that had been left over. And in part B, that we calculate the theoretical mass for hexafluorosilicate acid, and the mass is equal to 79.84 grams. And in part C, which we asked for to calculate the percent yield, and the answer is 57.36%. And in the final part D, it is a type of replacement.
Okay, thank you, Harry. You're a smart
Thank you,
kid.
everyone.